math, we are learning to identify patterns that we notice in the multiplication table. We're doing this so that we build a better understanding of what happens to numbers when we multiply them and when we use that operation. We learned the vocabulary words factor. A factor is a number that you are multiplying. And our product is our answer in a multiplication equation. So the first pattern that we looked at, or one of the first patterns we looked at, is called the multiplicative identity. And that is just a fancy way for saying 1 times any number equals that number. So if we look at the table, and we see that we have 1 times 1. 1 times 1 equals 1. It equals that number. 2 times 1 equals 2. 3 times 1 equals 3. 4 times 1 equals 4. 5, 6, 7, 8, 9, 10, 11, and 12. 1 times any number equals that number, or product of that number. And we can look at it this way too. 1 times 2 equals 2. 3, and so on and so forth. That is one pattern in the multiplication table. Then another pattern that we identified, if we look at our 5s, if we multiply a factor by 5, 5 times any number will give you a product that has a 5 or a 0 in the ones place. 5 times 1 equals 5. 5 times 2 equals 10. There's a 0 in the ones place. 5 times 3 equals 15. A 5 in the ones place. And so on and so forth right here. So that's one pattern. Another pattern that we identified in the multiplication table is that every multiplication fact has a twin, and we can call that the commutative property. If we look at the word commutative, we see the word commute in there. It starts with that commute, which means to move from place to place. Well, that way we can think about how our factors can be moved around in multiplication. 3 times 2 equals a product of 6, the same as 2 times 3 equals a product of 6. I can see that in the multiplication table. 2 times 3 equals 6. I can use the multiplication table this way too. 3 times 2 equals a product of 6 as well. Another pattern that you can identify in a multiplication table, if you look when you multiply numbers, we can use the 3s as an example. If I multiply 3 times 1, that equals a product of 3. 3 times 2 equals a product of 6. 3 times 3 equals a product of 9. And 3 times 4 is a product of 12. And then 3 times 5 equals 15. If I look at that, I notice that when I multiply a number, a factor by a factor, I'm skip counting. 3, 6, 9, 12, 15. When I'm multiplying by 3, I'm skip counting by 3s. If I'm multiplying by 4, I'm skip counting by 4s. If I'm multiplying by 5s, I'm skip counting by 5s. When we multiply a number, we are using skip counting. Another pattern that I can identify in a multiplication table is to think about when I multiply a factor by 10, my product will have a 0 in the ones place. So if I look at my 10s, 10 times 1 equals 10, a 0 in the ones place. 10 times 2 equals 20. 10 times 3 equals 30, and so on and so forth. I have a 0 in the ones place when I multiply by 10. Another pattern you can notice in the multiplication table is if we can look at odd and even numbers. When I multiply an odd factor by an odd factor, I get an odd product. For instance, if I look at 5 times 5, that equals a product of 25. It is an odd product. An odd number 5 multiplied by another odd number 5 equals an odd product. I can show another example of that. If I have 7, which is an odd number, and I multiply 7 times 9, which is another odd number, I'm going to get a product of 63, which is an odd number. Also, when I multiply an even factor by an even factor, I will get an even product. So if I multiply 2 times 2, that equals an even product of 4. 2 and 2, that's an even number, and I'm going to get an even product. If I multiply 8, which is an even number, by 6, 8 times 6 equals 48, which is an even product. And then finally, if I multiply an odd factor by an even factor, I will get an even product. So if I multiply 3, which is an odd factor, by 4, which is an even factor, that will equal an even product of 12. If I multiply, let's say I have an odd factor of 11, and I multiply 11 by an even factor 8, my answer, my product, is 88, which is an even product. This can be helpful when you want to check your answers, when you multiply even bigger numbers. When students start to multiply even bigger numbers, they can check the reasonableness of their answers by this pattern. We'll continue to learn about patterns in the multiplication table, and all of this learning will help support our conceptual understanding of multiplication.